Year 10 Probability. This is lesson number 1. In our introduction to probability, we'll go over the terminology, events and outcome, and do some simple calculations. So, events, in the language of probability, something could or has happened is called an event. The following are all events. Each one describes something that has happened or is going to happen. We initially talk about probability, talk about chances of something occurring, and if we use terminology, two terms we use at the extremes. If something is impossible, we say it has no chance of occurring. If something is certain to happen, we say it has a probability of 1. So all probabilities are between 0 and 1. There are other terms we can use in between. So the terminology like even chance we'd place in the middle. A poor chance somewhere between 0 and half, and a good chance somewhere between halfway and 1. The following events, where would we place them? So I'll give you a second to think about it, then I'll put the answer up. Mother giving birth to a baby girl. An even chance is correct. Getting a 4 in the spinner. If you have a look at the spinner there, there's 3 4s and 2 other numbers. So there's more than better half a chance of getting a 4, so we put it down in the good chance area. What's the probability of getting a 7 on the same spinner? Well, there's no 7, therefore it's impossible. Leaves falling off trees in autumn. Certain. Leaves fall off trees, not all trees, but it doesn't say all trees, does it? The next one, getting a 6 on a die being the singular of dice. There's 1 6 on there, so certainly not an even chance or a good chance or a certain, so it'd be somewhere down on the poor chance scale. And the probability of winning the Powerball jackpot, well, it's not impossible. Some people would like to think it is, but some people do win it each week, so the probability of winning is very small but not impossible. Outcomes. If we know all the possible outcomes can occur, then we can work out the probability. So this little slide's about listing outcomes. So we're going to make a list for all the possible things could occur for the following events. So the first one here, we're throwing a die. So we say what can happen. We can get the numbers 1, 2, 3, 4, 5 or 6. We say the outcomes for the event of throwing a die are all equally likely. A very common phrase used in probability. Tossing a coin, throwing a die produces 6 outcomes. Tossing a coin, I can have a head or a tail, so 2 outcomes. On this spinner here, it's 5 different colours, so there's 5 outcomes. If we list the outcomes of another event here I have a deck of cards. How many possible outcomes when you choose a cards from a pack? There's 52. Cards come up a lot in probability. So those who haven't played cards before, there's 4 suits. You can see there's the hearts, there's the clubs, the diamonds and the spades. This is ace through to 10, there's 10 cards. And there's 3 picture cards, or sometimes called the court cards, the jack, the queen and the king. And each suit has the same numbers of each one. Now, the definition of probability you should have met before is the probability of an event happening is the number of wanted outcomes over the total number of outcomes. Where would you place the following events on the probability line? Right, the first one here, getting a tail when tossing a coin. Well, there's 2 outcomes we said before, so the chance of getting a tail is 1 out of 2. On the scale here, it would be placed right here in the middle. And so it is. Getting a 3 when you throw a die, there's only 1 3 on a die, 6 numbers in total, so probably 1/6. This scale here is, you'll notice it's divided into 6 parts up to a half, and another 6, so each one is worth a twelfth. So probably getting a sixth is one, as getting a 3 is 1/6, which is the same as 2/12. You can see on our scale here, 1/12, 2/12 is the same as 1/6. Probability of being born in the month of March, well, 12 months in the year, so we expect 1 out of 12, so that's 1/12. Starting at 0, we've gone 1/12 across. Choosing a red cube random from the bag, we'll count them up here. There's 5 reds and there's 7 blues, so the number of reds is 5 out of 12. So they're 5/12. A half is 6/12. Getting a 5 in the spinner, how many 5s are there? There's 3. What's the total number of outcomes? 4. 3/4. So somewhere down here, in 12ths, 3/4 is the same as 9/12. And the last one, probably getting a blue bead from this bag. Well, they're all blue except that one red, so we have to count them up. There's 4, 5, 6, 7, 8, 9, 10, 11 blue. Looks like it's 11/12, which is almost at a whole. A little bit less, 1/12 less than a whole. Remember the probability of event happening, wanted outcomes over the total number. Right, now let's discuss the probabilities of the following events and their placement on the probability line. Not getting a tail when tossing coin, well, that's the same as saying getting a head, which is 1 out of 2. Not getting a 3 means I can get a 1, a 2, a 4, a 5 or a 6, so there'd be 5 out of 6 ways. Not being born in the month of March, there'd be 11 months you could be born in out of the 12. Not choosing a red from here means you're choosing a blue, so it'd be 7 out of 12. Not getting a 5 means only getting a 4, it's 1 out of 4. Not choosing a blue bead at random from the bag, well, there's only one non-blues, the red one there, and there was 12 there before, so it'd be 1 out of 12. You'll notice these are all the opposite to our previous slide. Fortunately, the probability of an event not happening is 1 minus the probability of it happening. Here, go back to our tossing coin, 1 minus a half is a half, same probability of getting a head or a tail. Probability of not getting a 3 was 5/6, probability of getting a 3 was 1/6. And they add up to a whole. So that's what this rule is explaining here. If we call event A symbolically, we say the probability of not A is equal to 1 minus the probability of A. Short way of writing not A is to have A dashed, which we literally read as not A, or A not. A bit like when Mr. Wayne tells a joke, everyone goes, "That's very funny, Mr. Wayne, not," with the not at the end. Okay, let's have a look. Probability of not happening. It's the same here, 1 minus the probability of A. Jenny has 12 cards, different shapes shown as shown. She turns the cards over and chooses one at random. Mark the probabilities for the chosen card on your number line. Right, the probability of a red shape. So we count up, there's 1, 2, 3, 4, 5, out of a total of 12. Probability of not red, oh, that's where it belongs, the number, that's 5/12 there. That's halfway, 6/12. Probability of not red, well, all the others are red, so it must be 7 out of the 12. So it goes there. You can see they're sort of symmetrical about the middle there, because they're the opposite of each other. Probability of a 3D shape, you can see here you've got the cylinder and the cube, so there's only 2, so 2 out of 12, which simplifies to 1/6, which is down here. And the probability of not a 3D shape, without having to count up, it'll be 10 out of 12 or 5/6, which will go down the opposite end. Probability of not triangular, well, there's 3 not triangular there, there's another 3 there, another 3, it looks like there's 9 not triangular, it's 3/4. Last one, not quadrilateral. Squares are quadrilateral, circles not. That's a quadrilateral, 4 sides. That's got 4 sides. That's got 4 sides. So it looks like there was 4 quadrilaterals. So not quadrilateral. There are 8 out of 12. So 2/3. And that would be placed there, 2/3 the way along the scale from 0 to 1. Alright, here I've got 6 cards. Turn over a card, and what's the probability of these events? Probability not even. Look for the odds. 1, 2, 3, 4. So 4 out of 6, or 2/3. Not prime. What's a prime number? A prime number is a number only divisible by itself and 1. 3 is prime. 17 is prime. 24 is not, because besides 1 and 24 going to 24, 2 goes into it, 3 goes into it, 4 goes into it, 6, 8, 12. 15's not prime because it has another pair of factors, 3 and 5. 7 is prime, 12's not. So our prime numbers were 3, 17 and 7, but not prime, 24, 12, 15. So 3 out of 6, which simplifies to 1/2. Not a multiple of 3. That is, not, is, not, is. So there's 2 out of the 6. It's 1/3. And that would be placed there in the number line. 4/12, same as 1/3. Not less than 18, so it means it's got to be over 18 or over. So anything less than 18 doesn't count. So those 4, 5 are all less than 18, but this one's not less than 18. So it's 1 out of 6, which goes there because that's 2/12, 1/6. Not greater than 20. There is one number greater than 20, so there's 5 not greater than 20, which goes way down here. 10/12, 5/6. Not less than 7 factors. So went through these before. 3 had 2 factors. 17's got 2. 24's got 1 and 24, 2 and 12, 4 and 6, and 3 and 8. So there's 8 factors. So certainly it's not less than 7. 15 only has 4 factors, 1, 3, 5 and 15. 7 has 2 factors because it's prime. 12 has 1 and 12, 2 and 6, 3 and 4, 6 factors. So it's not less than 7 factors. Not less than 7 factors. So 24 is the only one not less than. It's got more than 7 or more. It's got 8. 1 out of 6. Okay, here's another way problems can be written. This one talks about the events, the numbers from being 1 to 12. Let E be the set of even numbers. There's all these curly brackets here. It says these are all the possible things that belong to this group, but the overall group is only numbers 1 to 12. Let O be the odd numbers and let P be the prime numbers. So typical questions here, you might be asked to list the elements of the universal set, E, O and P. So in the universal set, so I've got to list them. That's all the possible numbers. The even ones, the even set, are 2, 4, 6, 8, 10, 12. The odd numbers, 1, 3, 5, 7. Right, and the list of prime numbers, one's not prime. Prime numbers have 2 factors. One only has 1 factor. So the prime numbers are 2, 3, 5, 7 and 11 up to 12. 2 is the only even prime number. Part B here says find the probability of these events. What's the probability it's even? How many evens are there? There's 6 out of 12, which simplifies to 1/2. Probability being prime, there's 5 numbers out of a total of 12. That can't be simplified. Probability being odd, there's 6 odds out of 12, simplifies to 1/2. An even prime. If you have a look, what's in the even group? Also in the prime group, there's only one number, and that's 2. So it'd be 1 out of 12. Even and not prime. So it's got to be even, so and not prime. So 2 is prime, so we take that out. So I'm left with the 5 others. So that'd be 5/12. Right, the work you need to do with these questions from exercise 8A. You should find the questions, the first set of questions up to about 5 or 6 or 7, pretty straightforward. Probably the challenging ones are down towards the bottom there where we get to questions 12, 13, 14 and 15. Good luck. Thank you.